Hey y'all, today we're going to talk about growth and initial value. So, if you have not watched my day one video that we did yesterday, please go back and watch that. It will help you get a lot of the basics and the foundation of this particular topic. So if you haven't, go ahead and pause this video, go back, watch the day one, and then come back and join us for day two. So let's look at the first problem. Avery is going to the fair. She has to pay an entrance fee, then buy tickets to get on the rides. The table below shows how much money she has spent on how many tickets she buys for rides. Answer the following questions. Okay, so let's go ahead and fill in our table and fill in the missing information. We learned yesterday that in order to find how much something is increasing, we need to do these little loop-de-loos. So on the top, we're going to do some little loop-de-loos. This is anytime you have a table. So 0 to 1 is adding 1. 1 to 2 is adding 1. 2 to 3 is adding 1. 3 to 4 is adding 1. 4 to 5, adding 1. Okay, so we know that our x value is adding 1 every single time. It's constant. Let's look at our y value. We don't know 0. We don't know 1. But we do have some data here that we can look at. 9 to 11 is plus 2. 11 to 13 is plus 2. And you always want to put your y over the x. Well, our y increase, the change in our y is 2. The change in our x is 1. Well, what is 2 over 1? 2. So it's increasing by 2 every single time. So now that we know that information, we can go ahead and fill in the missing information in our table. So, if at 4 tickets it was 13, and we're increasing by 2 every single time, as long as it's increasing by 1 on top, it did increase by 1, so on the bottom we can increase by 2, which makes 5 tickets 15. Okay, let's back up and fill in this information. If we're increasing by 1 on top every time and increasing by 2 on the bottom every time, in order to go backwards, you would need to decrease by 2. So 9 minus 2 would make 7. 7 minus 2 would make 5. So now that we've filled in our table, let's go ahead and fill in our missing information in our questions. So how much money does each ticket cost? Well, if you look at number of tickets and money spent, once you have done these loop-de-loos on the top and on the bottom, you know that the change in y over the change in x is how much each ticket cost. This is going to be your growth. So how much is this table growing by every single time? 2. It's growing by $2 every single time she buys another ticket. So each ticket costs $2. How much money has she spent when she has bought 5 tickets? So number of tickets, let's go to 5. Right there, $15. What about after 1 ticket? So let's find 1, and there it is, $7. Okay, let's look at question C. How much money has she spent before she buys any tickets? So she hasn't bought any tickets at all, but how much money did she spend? That is your initial value. It always lines up with 0. Your initial value. Before I buy any tickets, how much money did I spend? $5. I had to pay $5 to get in to go to the fair. Then I can start buying tickets for $2. How much money will she spend if she has to buy 100 tickets? Well, we learned that each ticket costs $2. So 2 times 100 equals 200. But that is not the answer. Don't write that. You've got to remember that you had to pay that entry fee. So you've got to add your $5 back in. So $205 is how much 100 tickets would cost. If you watched yesterday's video, you noticed that we created a little equation. So y equals, it would be 2x plus 5. Because 2 is our growth, 5 was our initial value. And you could just plug that 100 in right there and know that 2 times 100 was 200 plus your 5. Okay, so let's graph this data on this graph using our starting point as the entry fee. So let's look. If I don't have any tickets at all, right here at 0 tickets at all, how much money did we spend? We spent $5. So when we don't have any tickets, we're going to go up to money spent on the y-axis, and we're going to put a dot. Because number of tickets, 0. Number of money spent, 5. We're just lining up our table onto the graph. Number of tickets, 1 ticket was $7. So number of tickets, I'm going to go over to 1, and then I'm going to go up to money spent, $7. Make another dot. And your dots need to be on perfect lattice points. That means on crisscrossers, where the lines meet. 2 tickets was $9. So I'm going to go over to 2, up to 9, make a dot. Okay, 3 tickets. 3 was $11. So go over to 3, up to $11, make a dot. Okay, 4 tickets. 4 was $13. So go over to 4, up to 13, make a dot. And 5 tickets was $15. So I'm going to go over to 5 tickets, up to $15, and make a dot. Now, you have all of your information on your graph. You're going to now take a ruler. Once you get your ruler out, you are going to line up your dots so perfect. Make sure they are all touching the ruler. And you're going to create a perfect line. Now, my line is just a little bit above. It could actually come down a little bit more to cover the dots, but I wanted you to still see the dots. Okay, so let's look at the second table. Find the following information for the table. First off, let's start by doing our loop-de-loos. So, looking at this information, 0 to 1, plus 1. 1 to 2, plus 1. 2 to 3, plus 1. Let's fill in our information on the bottom. We don't know 0 yet, but we can find that out after we solve our growth for the rest of the table. 4 to 5, plus 1. 5 to 6, plus 1. So if we're adding 1 every time, and on the bottom we're adding 1 every single time, so how would we go backwards to find out our 0 value? By subtracting 1. So 3 is the missing value there. So what is the growth of this table? Remember, the change in y over the change in x is your growth. Well, what was happening every single time on the bottom? Plus 1. What was happening every single time on the top? Plus 1. What is 1 over 1? 1. So the growth of this table is adding 1 every time. What is the starting point? Remember, I've taught you that the starting point is always your initial value. Your initial value is what lines up with the 0 as long as the 0 is in the x spot. So the initial value for this table is 3. Graph the coordinates from the table. So like we did just a minute ago, we're just going to graph this information. The x-axis runs side to side. The y-axis runs up and down. So our first x point is 0. Our first y point is 3. So 0, and then I'm going to go up to 3. Your initial value will always be on that y-axis. 1, 4. So go over to 1, up to 4, make a dot. The next one is 2, 5. So we're going to go over to 2, up to 5, make a dot. Our next one is 3, 6. So over to 3, up to 6, make a dot. Get your ruler. Draw a nice, perfect straight line. Put your arrows on it. Now, let's look at D. Is the starting point on the y or x axis? So, this is the x axis. This is the y axis. Your starting point is your initial value. Where was that 0, 3 dot located? On the y axis. Where can you see growth when looking at the points on the graph? So you can see growth by adding on a table, but on a graph, where would you find growth? You can look to see what's happening every single time between the points. So this was 0, 3 to get to 1, 4, to get to 2, 5, to get to 3, 6, and it would have continued to get to 4, 7. How can we see that growth? It's going from that point to that point to that point to that point. You can actually go up and over, up and over, up and over. That's called your rise over run. Rise over run. How much you rise? We went from 3 to 4, so that was 1. And then how much did we run? We went from 0 to 1, because this is the 0 marker, 0 to 1. So we rose 1, we ran 1. So 1 over 1 equals 1. And that's the same thing you got on the table. Now you're getting it from the graph. Can you figure out how many tiles are in the 100th figure? If you go back to what we talked about with that rule, y equals mx plus b. Looking at that rule, remember x is where you always want to put in the tile you're looking for, the item you're looking for. So our growth here was 1, so it would be y equals 1x. Remember, b is always your initial value, so plus positive 3. So if I take that 100, I'm going to plug it in for x. 1 times 100 plus 3. So how many would be in the 100th figure? 103. I hope this helps y'all. Have a great day. Bye.